Okay, so that's just some examples of evidence of chemical reactions. And now what we want to do, find my pen, is take a look at getting a look at equations. And the first thing I want to talk a little bit about is word equations versus formula equations. Just as the definition says, word equations is a way of writing out what's happening with words. Formula equations, of course, would be then using formulas. So, for example, hydrogen reacts with hydrogen reacts with oxygen to produce water. That would be your word equation. Please know that you could say that in many different ways. You could say, and I just want to make sure you recognize, okay, hydrogen reacts with oxygen, so we hopefully know that those are our reactants, and with to produce water, this would be our product. All right, now we could write that or use a word equation such as water is a product of the reaction between hydrogen and oxygen. Okay, again, I'm not going to write out the whole words, but notice different way of writing it means the exact same thing. Hopefully you should recognize which one's the reactants, which one are the products. But again, those are your word equations. You'll see terms like yields. Yield is a great way of saying to produce, okay? So in chemistry we use the term yield a lot, okay? So those are your word equations. Talking about formula equations, here you are. Hydrogen reacts with oxygen. Notice we put a plus sign to show reacts with, whoops, I should have circled the whole thing, reacts with, and then to produce. In chemistry we use an arrow, we don't use an equal sign. So recognize if we have two or more reactants or products, we use an addition sign, but to produce we use an arrow. And you'll see as we move along that sometimes that arrow is written as both directions because all reactions are reversible, but I just put a single arrow. Okay, so there's a formula equation. Here's another example of a word equation. Calcium and oxygen react to form. Notice it's just written a little bit differently than the top one. To form calcium oxide. And here we are, calcium and oxygen react to form calcium oxide. Now what's important that you realize is two things, and I chose these two examples to remind you this. First, hydrogen and oxygen down in here, are what's called a diatomic element. And diatomic means two atoms. So whenever hydrogen is alone, so the term hydrogen reacts with oxygen, notice it says just alone, it's not a compound, it's never alone. Diatomic means there's always two atoms when we write out this element. There are 7. I like to think of them this way. We have, let me just move this over here. Hydrogen, whenever it's alone, it's never alone. Then nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, these are the 7 diatomic elements. 7 diatomic elements, and here they are. The reason I write them this way, and I kind of wanted to write it this way, is because we have hydrogen, which is number 1 on the periodic table. Then nitrogen. Nitrogen's number 7 on the periodic table. So I remember that there are 7 diatomic elements. Let's go after hydrogen, which is kind of on its own, it's a gas. We go to nitrogen, which is the next, not counting helium, the next gas on your periodic table. So if you look at it, my periodic table has red symbols for nitrogen. Nitrogen, oxygen, fluorine, chlorine, bromine, it looks like a 7. So here's that little hint of 7s. There are 7 diatomic elements. We have hydrogen, and then we go to number 7, atomic number 7, nitrogen, and then it looks like a 7. Why? Well, because number 7 is nitrogen, number 8 is oxygen, number 9 is fluorine. Then when you go down the halogens, we've got chlorine, which is 17, bromine, which is 35, and iodine, which is 53. But again, that's just going to be that 7. To me, it looks like a 7 on the periodic table. All right, so again, when you see that they're alone, hydrogen, oxygen, oxygen, they always have two. So hydrogen or oxygen or any of these other 5 are never alone. Notice the difference with calcium. Calcium is not a diatomic element, so there's only one. We don't write Ca2, okay? Very important to recognize when you write these diatomics down or you have any kind of reaction with that. Now the other little wrinkle that I wanted you to see, and it's very important when you're writing the chemical formula or the formula equation, is this. Calcium oxide. We need to know that calcium oxide is written properly. How is it written? You need to balance the charges. It's an ionic compound. So you should, and again, I just kind of CaO. I know that that's what it is, but calcium is a 2+. I know that because it's in the alkaline earth metals. It has a 2+ charge. Oxygen is a 2-. So we've got a 2+, a 2-. We need to balance the charges when we write a correct ionic compound. And so CaO. All right, and notice that. I didn't carry my 2 here from the oxygen and write that down over here, CaO2. This is not correct, obviously, because if we had 2 O's, that would be a 4-, and that certainly doesn't balance off the 1 calcium, which has a 2 positive charge. Okay, so this is not correct. So again, whenever you write the formula equation from a word equation, you need to write the correct formula for that compound. Okay, and we're going to take a look at more examples, but just realize that. If this would have been calcium reacts with chlorine to calcium and chlorine react to form calcium chloride, then the formula equation would be calcium. It's not a diatomic, so we can write the calcium. Reacts with chlorine. Chlorine is one of those diatomics, so it's Cl2. And then calcium chloride, you might want to take the second to say calcium's a 2+ charge. Chlorine, I look it up on the periodic table, is a 1-. We've got our 2+, 1-. I need to have 2 chlorines to balance that 2+ charge, so CaCl2. Notice again we have 2 and 2. Now I know some of you are already saying, well, we are not following the law of conservation with the amounts there. We're not. We're going to balance the equations later, but first step is you must write the correct formulas. Calcium oxide is CaO, calcium chloride is CaCl2. We'll take care of the amounts later in order to follow the law of conservation. All right?